Cool, thank you very much. Hopefully everyone can see my screen, and thank you for having me here today. So yes, my name is Jason Mays. I am the developer advocate for TensorFlow.js at Google. And what that basically means is that if you're using machine learning in JavaScript, I'm magically going to pop up at some point and our paths will probably cross. So on that note, a little bit about my background here. Essentially, I've been using JavaScript for over half my life. If there's one key thing you take away from this slide, it is I've used it since its very early stages. It's very humble beginnings where it had some issues maybe, but now it's matured into a very robust language that's used in production systems by over 2/3 of developers globally, which is a pretty impressive feat. But why should we care about machine learning in JavaScript? And that's a good question. So I'd like to go through some of these details now. First of all, you can use machine learning anywhere JavaScript can run. And JavaScript can run in the browser, on the server side, on desktop native apps, mobile native apps, and Internet of Things. And JavaScript is the only language that can run across all those devices without any third-party plugins and other requirements. And if we dive into the stack a little bit more, you can see many of the technologies that you know and love already, or at least heard of. On the left there, we've got all the kind of popular browsers that you might be using. Server side, you've got Node.js. On mobile, we support React Native. We've got WeChat and progressive web apps. On desktop, you've got Electron. And of course, on Internet of Things, you've got stuff like the Raspberry Pi that you can support via Node.js. So it's a very powerful language that can run pretty much anywhere. Now, with TensorFlow.js, of course, you can retrain via transfer learning, and of course, you can write new machine learning models from scratch if you so desire, just like you do currently in Python if you're already using Python. So no differences there. And that, of course, means you can dream up anything from augmented reality, sound recognition, conversational AI, whatever you want to do, you can also do in JavaScript. So I want to go through the three kind of flavors of TensorFlow.js and how you might get started using it. First up, we have a bunch of pre-trained models that are available, and these are super easy to use JavaScript classes for common use cases. And of course, not all the time you need to reinvent the wheel. Sometimes to do certain things, you can take an existing model and use it. So you can see here, we've got a number of models that are packaged up in a nice, easy to use way, from object detection, body segmentation, pose estimation, and all the other things you can see on the slide. Some of our newer models include face mesh for landmark detection on faces, hand pose, which is similar for hands, and of course, BERT Q&A model to do that kind of natural language processing in the browser. And all of these things run in the web browser. And I want to show you what the performance of some of these are. So let's dive into some of these right now. Now, so the first one is object recognition. This is using Coco SSD model behind the scenes, which is being trained on 90 object classes. And you can see here, this gives back the bounding box information that allows you to then highlight the objects it discovers in a given image. So if I just exit this presentation a second and go over to my demo, you can see here that as I click on an image in real time, I'm getting the classifications coming back. And note how fast that is. This is just running in Chrome, as you can see. This is my Chrome web browser. But if I enable my webcam over here, you can see that I can get real-time predictions coming back as well. And of course, I need to change the confidence there, but you can see that it recognizes me with a 90% confidence as a person, which is obviously very good. This is running in the web browser in real time with high performance. And we can then use this for very interesting applications. So if I jump back to the presentation and present, next up we have, wait to load, 2 seconds here. There we go. Next up we have face mesh. This is a model that is just 3 megabytes in size, and it can recognize 468 facial landmarks on the human face, as you can see in this nice GIF. And that allows you to do some very interesting things. You can see here, Modiface, which is owned by L'Oreal, have created this augmented reality app that allows you to try on makeup before you purchase the makeup. So this lady that you see on the image on the right-hand side has selected a shade of the lipstick, and we're applying it using face mesh to her face in a very realistic way and taking into consideration the lighting and other such things. So once again, I've got a demo for you for this one. I just want to show you some of the benefits of using the face mesh model. And you can see here, this is once again running in my web browser. And I can move my face around, and everything is working in real time here. And as I open and close my mouth, you can see that happening as well. Now, notice that we still are able to have enough processing power left over to do a nice 3D visualization on the right-hand side here. You can see me rendering those points as a point cloud using WebGL. So there's plenty of horsepower in JavaScript to do really advanced and complex graphics simulations like this. And it's a very mature language for that. From day one, JavaScript has basically been there trying to present things on devices. And you can see it's very well attuned for doing this. Now notice I'm getting about 20 frames per second right now. And that's actually because this is running on a CPU only at this point. If I switch the backend out to run on WebGL, which is then going to leverage the graphics card, we'll basically load the new backend in, and in a few seconds, it will switch out, and hopefully, here we go. And now, as I move around, you can see we are getting a better, why is the frames per second not changing? Okay, live demos. When I did this earlier, I think it's because I'm live streaming at the same time or something like this. I was getting closer to 45 frames per second. But basically, you can get faster performance on the graphics card typically. So that's something to bear in mind. And TensorFlow.js will automatically select the right backend for you at runtime by itself, which is a quite nice feature to have. Cool. Back to the presentation. Let's go back in here. Wait for load. Okay, cool. Next up, we have body segmentation. Essentially, this allows you to distinguish 24 different body areas of the human body across multiple bodies, all in real time. I'd love to show you the demo of this, but it's really hard for me in my bedroom right now to actually do this, to get my whole body in shots. So I'm just going to do this GIF. But you can see there on the right-hand side that the segmentation is working pretty nicely, and it even gives you the pose estimation for the skeleton as well. That allows you to do some really interesting things. And on that note, it can be used in really delightful ways. So any of the models you've just seen can be used in unexpected ways that can be very creative as well. Here's two examples I created in my spare time. On the left-hand side, you can see how I remove myself from the webcam in real time as I walk around the bedroom. And notice how I go on the bed, the actual bed is still distorting, but my body is removed. So you get this kind of ghostly effect. And you can see it's not perfect. You see the arm just showed there for a split second, and that's okay. This is just a prototype. I made it in less than 1 day. So this is not designed to be perfect right now, but you can see how you can very rapidly prototype these things. And then, of course, you could go and fine-tune the model and do your transfer learning to perfect it, to find those edge cases that are not working properly and make sure it does in the future. So this is a very nice way to rapidly innovate. And on the right-hand side here, you can see a demo that I created to estimate your clothing size, also using the BodyPix body segmentation model. And you know, I personally, I don't know about you guys out there, but I personally find it really hard to know what clothing size I am when I need to buy new clothes. I never remember it. So I made this little tool to help me that will measure me in real time and then tell me if I'm a small or a medium based on the brand that I'm trying to buy from, because every brand is different, right? So this can also lead to giving you superpowers. If you go beyond just machine learning and combine TensorFlow.js with other web technologies, such as WebGL shaders that you can see here, this guy has literally turned himself into Iron Man. And I don't know about you, but when I was a kid, I was promised all these things as a kid, that one day we'd have all these kind of sci-fi technologies and things. And now we can literally shoot lasers from our eyes and from our mouths, which is quite fun. And along these lines, if you combine it with even more technologies, the web has things like WebXR, which allows you to do mixed reality. And you combine that with WebGL to get these particle effects and TensorFlow.js for the machine learning. And one of our community members from France has essentially managed to recognize any body from a magazine or a book, and then bring that into his living room all in real time, and then allows you to go up and walk around it and inspect it. And this is just really cool. This is running on a mobile device. But you can see the performance is really, really nice. So that brings me on to the second section, which is all about transfer learning. Essentially, this allows you to retrain models that currently exist with your own data. And there's certain situations when you might want to do that. Maybe for our Coco SSD example earlier, you want to recognize bananas rather than cats and dogs. And if it wasn't trained on that before, then of course you need to tell it how to learn how to recognize those new things. And in TensorFlow.js, of course, we can do that in a number of ways. Now, of course, if you're more used to TensorFlow, you can, of course, program this to happen in code. But if you want to get started in an easier fashion, I want to just point out two other methods you can also use that are working with TensorFlow.js right now. The first one is teachable machine that you can see here. And this is all happening within the web browser. So it's actually going to do the transfer learning in the web browser itself, and allows you to reclassify for object detection, sound recognition, and body pose estimation. So you could actually do all of those things with Teachable Machine. And I believe they're going to increase the things they support as we go into the future. So I just want to show you that in action right now, because this is like really amazing how fast this can work. So this is Teachable Machine. You can see my screen here. And if I click on class 1 and click on the webcam, I can just take a few sample images of my face here. So I've got about 44 sample images of my face. And then if I go to class 2 and click on webcam and hold up this deck of cards that I've got, and I just kind of move that around the screen as well, and I've got around a similar number of images, 38 image samples there. I click on train model, and now, of course, the model is being retrained with that new data. It's adding a layer to the top of I believe it's one of our mobile net models or something like this. And in just a few seconds, it's now retrained. And that all happens in the web browser. So all of my privacy is preserved. None of those images that I took have ever been sent to a third-party server. So it's nice and private, which is good when you're using things from the webcam. And as you can see, it now gives me a live output on the right-hand side here that allows me to test the model that I've just trained. And you can see right now it's predicting class 1. And if I move my deck of cards in, it predicts class 2. Class 1, 2. And see how performant that is. It's working really fast in the web browser in real time. Now, if that's good enough for your prototype, then of course you can export that model, and you can dump a JSON file with all the model weights and all that kind of fun stuff that you can then host on your website and then run on any device you like, with a nice graphical user interface, and you add all the nice fanciness for that. So just in under a minute, I believe, we've managed to make a machine learning model that works to classify me versus a deck of cards. And of course, that's not going to be robust. And there's some situations where for production, we need to go much deeper with the training data and tweaking hyperparameters and all this fun stuff. But thankfully for that, we actually have something for that as well. So let me just go back to the presentation. And next up, we have AutoML. So if you want to make production level systems with your own custom training data, you can do that with Cloud AutoML. Now, right now, the custom vision models are the things that you can train and deploy to TensorFlow.js. Once again, I'm sure that will eventually expand, but right now it's mainly for vision. So you can see here, someone's trying to classify different types of flowers. So all they've done is they've got a bunch of folders with labeled photos inside, and they've uploaded that to the Google Cloud Platform. Now, on the second step, all you need to do is now specify how do you want to train the model. Do you want to specify higher accuracy or a trade-off between faster predictions? And you can kind of choose which path you want to take depending on your use case and where you want to run this model. And what will happen then is that you set how many hours you want to train for and what your budget is, and Google will go and try and use various different machine learning models behind the scenes with hundreds of different hyperparameters, and it will come back to you and essentially tell you which one was the best, and it will deliver that for you to download. So it's essentially machine learning, training machine learning to allow you to make the models, which is pretty cool. So on the next step, you can see you've got this export button that allows you to export to TensorFlow.js, and that gives you the JSON file that you need to then use on your website to then classify things. And how might you do this, you may ask? It's actually super simple. Here is the code. If you're familiar with HTML and JavaScript, this should be pretty self-explanatory, but for those who are not, I'm just going to go through this right now. But at the top here, you can see two script tags. The first one just simply imports the TensorFlow.js library, and the second one imports the Cloud AutoML library. So they're just imports, essentially. On the third line here, we've got the image tag. This is an image for something that we're trying to classify. So this is a new image that the model has not seen before, but we're trying to classify live in the web browser. Now, down below, we've got 3 lines of JavaScript essentially that does the actual work. So the first line here that starts with the const model, essentially all we're doing here is we're loading the model. You can see on the right, we're referencing the model.json file that's hosted somewhere on our web server, and we wait for that to load. Once that's loaded, we can then grab a reference to the daisy image that we have in our HTML there. So get element by ID daisy, and you can see at the top there the ID is daisy, so we just get a reference to that image. And then we can pass that image to our model to classify, calling the .classify function, and we await the results to come back to our predictions variable. And all that's contained in that predictions variable is a JSON object, which has all the data returned from the machine learning classification. So Of course, JSON is just JavaScript object notation, so that can be easily used in JavaScript because you can just treat it like an object and access all properties. So really easy to use and then display the results as you please. So the third part of this, of course, is that you might want to write your own code from scratch. And I'm sure a lot of people who are on the call today are already familiar with Python and writing their own models and so on and so forth. So I'm not going to go over how to do that because it's actually very similar. It's the same APIs in TensorFlow.js as you have in Python. But I want to focus on some of the superpowers and performance benefits you can get if you are running in JS. So first of all, just a quick overview of the APIs for those not so familiar. Essentially, we have two. We have something called the layers API, which is akin to Keras in Python. It's a nice high-level API you can use if you so desire. And then we've got the ops API, which is the more mathematical API, like the original TensorFlow one that you might be used to as well. So we support both of those. And if you're familiar with either of those in Python, it's pretty much a one-to-one translation. So long as you know how to write JavaScript, you can call these functions in much the same way as you would in Python. So the overview, as you can see here, is essentially you've got the pre-trained models that we've created at the very top there. That sits on top of the layers API. The layers API sits on top of the core ops API, which is the mathematical one. And then that can go to various different environments that JavaScript can run. So on the side, you have the browser, WeChat, React Native, all those kinds of things that we saw on the first few slides. And each one of those clients know how to run on different types of hardware, such as the CPU, WebGL for the GPU, and WASM, which is WebAssembly, which gives you better performance on the CPU if it is supported. And each one of those client-side environments knows which backend it supports, and it will use the appropriate one pretty much automatically. Or you can choose to force one if you really want to. So it's up to you as a developer. On the server-side story, pretty much the same kind of thing, except over in Node.js. And Node.js can talk to the TF-CPU and TF-GPU, which basically means that you've got the same C bindings as you do in Python. So you're going to get much the same performance as you do in Python. There's really not much difference. So you can access the C bindings that give you that processor performance for all the ADX instructions and that kind of stuff. And you've also got the CUDA support for the GPU as well. So you can leverage those fully on the server-side environment. So putting it all together here, essentially, you can load in Keras models using the layers API. You can load in a TensorFlow saved model from Python using the ops API, and that does not need conversion. So if you do choose to continue doing your machine learning in Python, that's completely fine. But if you find that you want to deploy to a web environment and you want to get a Node.js engineer to integrate that somehow with the web server, the Node.js engineer can now take that without conversion and run it in Node.js for free, which is really nice. And if you do want to convert to run on the client side in the web browser, for example, we've got a nice command line TF.js converter that can run on a saved model from Python, and it will convert it into the JSON format that you need to execute in the web browser environment. Cool. So a note on performance. We spoke about that very briefly earlier, and let's take a look at performance in JavaScript versus Python. As you can see, when you're running on CUDA on a 1080 GTX, and here we're running the MobileNet model, you can see in Python we get 7.98 milliseconds, and in TensorFlow.js, using Node.js, we get 8.81. So that's just 0.2 of a millisecond difference, which is pretty much negligible. Similar story on the CPU. On Python, we get 20.5 milliseconds, and in Node.js, 23. So really not much difference at all. Now, the really interesting thing happens is when you have a lot of pre or post processing. So note that these performance times are just for the model inference only, okay? Now, if you have a lot of pre or post processing, and in some situations you might have that where the model needs the data to be processed into a certain format so it can be digested correctly. If you have a lot of that going on, then if you do that pre-processing layer in Node.js, you can get extremely good performance benefits because of the just-in-time compiler that JavaScript has. We've actually seen with Hugging Face, which are pretty famous for their natural language processing models, for the Distill-BERT implementation, they converted that to Node.js so that all the pre-processing was done in Node, and then did the execution using our saved model interface. They got a 2 times performance speed boost by doing that, which is pretty significant. So I do encourage you to check this out if you are trying to deploy to a large environment like the web you might end up getting a performance boost for your pre and post processing, which is pretty nice. Now, if we focus on the client side for just a second and think about what benefits we have on the client side, some of these things are harder or impossible to achieve in the server-side environment. So first up is privacy. If you are executing on the client directly, then none of the data from the sensors is ever being sent to the server side. So then you're maintaining the client's privacy. And that's particularly important these days when it's top of everyone's minds, but also for certain industries like the medical industry or the legal industry, you might be restricted from actually transferring that data to a third party. So with TensorFlow.js, you get that for free, essentially. Second up is lower latency. Because there's no round trip time to a server, there's no latency in that sense. So there's no 100 milliseconds wait for that mobile network to get started and connect to the server and give the results back. We can talk directly to the sensors and then just pass it straight to the model for super buttery smooth performance. Third point, lower cost. As you're not running any servers with those costly GPUs and lots of RAM in the cloud, then you can literally save tens of thousands of dollars for a reasonably sized system over the course of its lifetime. Point 4 is interactivity. JavaScript has been designed pretty much from day one to share information. It's really good for graphical user interfaces and for graphics. And there's a lot of mature libraries you can use that are much more advanced than other languages right now in JavaScript for graphics because of that reason. It basically started with that. And then the fifth point is reach and scale. Of course, in order to run any of our models in the browser, all you need to do is click on a web link and load it in your browser. Anyone, including my mum and anyone else, can just click a link and it works. There's no need to understand how to set up Ubuntu or whatever Linux flavor you prefer, how to install all the CUDA drivers, how to install the TensorFlow dependencies, and then how to git clone all your repositories that you want to run, and then figure out from that documentation how on earth you actually run the darn thing with your own data. In this case, all you need to do is click a link and it just works. And currently, the GPU support is supported on 84% of devices globally via our WebGL implementation. And this is really cool because we essentially do the mathematics by using graphics. So we use textures and shaders in order to do the mathematics that you need for machine learning. And that gives us a much wider support. Running on NVIDIA graphics cards on the server, we can run on an AMD graphics card. And if you've got a MacBook, we can run on those too. So you get a really large reach and scale. And for people who might be on the research side, that might be really cool because you can get a lot of feedback on your cutting edge machine learning model from people out in the real world. You might find some edge cases or biases that you didn't consider when only doing it with a few people on your team in your research group. So the reach and scale could be a very important factor for some people. Flipping to the server side for just a second, there's a few benefits if you use this on the server side as well. And then, of course, certain situations when you have to work on the server side. So first of all, as we mentioned before, you can use the TensorFlow saved model format without conversion. So if you do prefer to use Python, that's completely fine. But you can then integrate with the web community in a much easier way via Node.js. Of course, if you want to run larger models than you can on the client side, then the server-side environment is the only place to do that. So on the client side in the web browser, I believe most web browsers limit the amount of RAM you can use to like 100 megabytes or something like this. So if your model is using more memory than that, then it's simply not going to run on the client side. Nor do you probably want to push 100 megabytes down the pipe to a little mobile phone or something like this. So in that case, you want to work on the server side. So you can run that on the server. Point 3, it allows you to code in one language. Now, I know people on this call will be Python programmers, that's completely fine, but 67% of people actually use JavaScript in development already. This is taken from the Stack Overflow developer survey of 2019. So 2/3 of people actually use JavaScript as their production language. So if you are one of that 67%, then there's no need to learn another language just to do machine learning. And you can take those machine learning models that are trained in Python and use it within your Node.js environment on the server side, which is pretty powerful. Fourth point, the NPM ecosystem is super large. There's tons of cool libraries, as I spoke about before, graphics and helper functions, all that kind of stuff exists in Node. That community is now pretty mature. And then the final point, of course, as we mentioned before, is the performance. We've got the same seed bindings as Python, so pretty much the same performance as Python for the model inference, but you do get that just-in-time compiler boost for all that pre and post processing that you might be doing for your machine learning models. So do have a play with that and see if that helps you out in your whole stack, if you get a better performance boost for the whole stack. So finally, I just want to end with some resources that you can use to get started, essentially. This is a slide that you want to take a screenshot of. Essentially, you can go to our website, TensorFlow.org/JS, and of course, our API is available there and lots of documentation to help you get started. Our models are also available on that website. I actually am a little bit behind in transferring all of our models from GitHub to our website. So if you click on any one of those models, it will take you through to our GitHub repository, which you can then find all of our models contained within that. If you are interested in contributing, of course, TensorFlow.js is fully open source. We have our GitHub link there as well. And if you have any really low-level technical nerdy questions, then check out our Google group mailing list, as I've only been on the team 3 months, in fact. So if you've got really low-level questions, that's probably best directed there for now, where the other people on my team can also help answer those. Now, if you are taking your first steps of machine learning or new to JavaScript, then I highly recommend the book on the right-hand side, Deep Learning with JavaScript. That was written by many of the people on my team and the wider TensorFlow community at Google. And it's a really solid book. I started with this myself, and it's really, really well written. So highly recommended. And then I guess the only thing I have for you is come join our community. Here's just a few examples of things that I've seen people make in the last week online. And people are getting very creative right now, which is super fun to see. And if you do make anything in TensorFlow.js, please do use the hashtag #MadeWithTF.js so I can find it and hopefully feature you at one of our future show and tells with the rest of our community as well. That'd be really awesome. And so basically, what will you make? Here's just one more piece of inspiration for you before I leave. This guy from Japan, he's actually a dancer, and he's managed to take TensorFlow.js and create this awesome hip-hop video using this kind of semi-transparent invisible effect using our body pics model. So now machine learning really is for everyone, no matter what your background. I personally am super excited to see where the creative community take this. We're no longer just confined to the command line. We can use graphics and other things as well to take it to the next level. So I'm really excited to see where things go in the future. So with that, feel free to stay in touch. I'm available on Twitter and LinkedIn. And of course, please do feel free to use that hashtag #MadeWithTF.js if you make anything cool. Thank you for listening.
Thank you, Jason. Yeah, really, really great talk, and great to see a kind of creative spin on machine learning. A lot of the earlier stuff we were hearing in machine learning was about very narrow AI tasks in banking, things like that. But really great to see the kind of horizon really expand with some of the stuff you're talking about. Okay, I'm going to dive into some questions. So first, George was saying, I love teachable machine learning. I've used for a project proof of concept, easy to roll a demo in a single day. He carries on with some other stuff. And then George asked, can you please share any extra tips or tricks on converting / optimizing to and from TensorFlow.js models?
So in terms of conversion from, is that from Python, I presume? The saved model format in Python? Or is he talking about TensorFlow.js ones specifically? From Python. Yeah. So the only tool we have available for that right now is the command line tool. That's the TF.js converter that allows you to take a saved model and then put it into the JSON format that we need to run in the web browser. Now, there are some caveats to that. If you're running in the Node.js environment, you don't need to do the conversion in the first place, so that point is mute. But if you are running in the web browser, you are limited by that 100 megabyte limit in the web browser. So you need to make sure that the resulting model is well under that in order for it to perform nicely on the client side. And then the second point is that for the client-side implementation, we currently don't support all the ops that TensorFlow core does support. Now in Node.js, that's not a problem. We have all the stuff going on over there. But on the client side, because we're using WebGL to implement the graphics card acceleration versus CUDA, we've only been able to port like the 500 most popular ops, for example. Of course, we hope that changes with time. We're working hard to deliver more ops, but you'll find some models, if they use very strange ops or more exotic things, that they won't convert, and the converter will basically bail and tell you why that is. So for those situations, you'll have to convert those ops to things that we do support if you want that to work properly. So that is the kind of process right now, and it's a case-by-case basis, unfortunately. I can't go into more detail than that. It's a case-by-case basis. But yeah, ideally, you want to get the model size down by pruning the network if you can, and all that kind of stuff.
All right, nice one. I'll come back to your second question in a moment, George. Dennis de Cruz, where can we learn more about TensorFlow.js? Is there a specific course you would recommend?
So honestly, the book I recommended is really easy to read. It goes from complete beginner. If you aren't familiar with machine learning, it actually starts chapter 1. It gives you the background on all of that. And then it pretty quickly starts diving into actual real world examples and things you can use. So it's a really robust book. It goes from everything from simple kind of regression kind of stuff to GANs and more. So like it really covers everything. And it's a great resource to get started. If you do prefer like an online kind of course, I believe one of my colleagues, Lawrence, has a course on Coursera that has some basics for TensorFlow.js and TensorFlow generally as well. But as we're quite a new team, we're still in the process of making new courses. There's also another course by our community, a guy called Gant. If you just search Gant and TensorFlow.js on Twitter, you'll find his course that goes into how to actually learn how to use tensors themselves and tensor operations and all this kind of stuff. So if you're looking to go more low level, then Gant's course could be a good introduction to the tensor level APIs as well. So those are the ones I'd recommend at this point.
All right, solid. Okay, Vicas, performance-wise, which is better, Python or JS? I recently moved from C++ to Python. Should we plan to switch to Java? Will there be TensorFlow.c++ in the future?
So I can't speak to the C++ stuff. I'm not on that team. In terms of performance, as you saw, we basically have the same performance as Python because we share the same bindings. Python actually talks to the C bindings behind the scenes, and our Node.js implementation does exactly the same thing. So for model inference, performance should be pretty much the same, and it basically comes down to what you prefer to code in. And I'm not going to preach on what you should do there. It's completely up to you. If you're more experienced in Python, feel free to use Python. If you are more experienced in JavaScript, feel free to use JavaScript within Node.js. The only thing where I would say it's advantageous to use JS is if you do want to have that reach and scale of the web, then your only option is to convert the TF.js format so you can run it in a web browser and that kind of stuff. And that gives you the other benefits like cost and other things as well. So that's the only case where you might want to convert a Python thing to a JS format if you're traditionally a Python programmer. But otherwise, use what you're used to. And this is just another way to have fun with machine learning, essentially. So, yeah.
All right, great stuff. So we'll dive into 2 more questions. So Sheila Rani, Sheila, researcher from Satyabama University, India. She says, you've explained with JavaScript, is it possible to do it with MATLAB?
I have very little experience of MATLAB. I'm not the best person to answer that question, unfortunately. I'm sure someone else might be able to comment, but as far as I'm aware, I don't know. I can't answer that. I've not used MATLAB in.
No worries. Okay, Chris Tompkinson. Chris says, great talk. How can you keep the code hidden if built into the client side, brackets, website code? Second part of the question. Is the solution to instead code, where is that question gone? Sorry, the question's, okay, there it is, yeah. Great talk. How can you keep the code hidden if built into the client side, brackets, website code? Is the solution to instead code this on the server and so build in a barrier that way, brackets, to hide the TensorFlow code from the user?
Yeah. So if you are concerned about your model being used by others, maybe you've made something that no one's ever done and you want to make that proprietary for some reason and make sure no one can touch it, then right now, I believe the only way to do that is to host that model within Node.js on the server-side environment and then just pipe over WebSockets the results. However, our team is looking into ways to protect the model in the client side, but that's not a thing right now. That's an ongoing research project for our team. So watch for space. Hopefully that might change in the future, but no promises, of course. But it's something we're looking into. So for now, yes, you need to use it on server side to protect the model if you don't want people to kind of take the model and use it somewhere else. Yeah. Okay,
cool. Okay, great. So we're going to dive into the, actually going to do one more last question, George.
Yeah.
So George said, FAIK, so a fake Firebase, which can be used to deploy versions TensorFlow.js models, which is great. What are the recommendations you have for managing or versioning models?
For the version of models, I guess, I mean, the way we do it right now is we have all our GitHub repos with our models pushed there, and then those we push to various content delivery networks like JS Deliver and these kinds of places that do the versioning for us. So we actually just push it to these kind of third-party systems that have this capability already. So I guess use whatever you're familiar with there. If you're familiar with GitHub and other things like this, you can push new versions via that. And then from there, you can go to NPM and other ecosystems as you see fit. So just, yeah, wherever your users are trying to use your model, I guess, is the best way to deliver that.
Okay, cool. Great. Okay, guys, so that's all we've got time for tonight. Just want to thank everyone for continuing to support TensorFlow London, and thank the speakers, Jason and David, for joining us.